Okay. Programmable logic controller or PLC overview. Objectives. Describe the history and development of programmable logic controller PLC systems. Does anybody in the room know who the father of PLC is?
General Motors?
No. That's who it was invented for, but who invented it?
Dick something. I just
You're on the right track. Anybody else? Hmm? Incorrect. Good try. Dick Morley. Yeah, Dick Morley was the one that invented the PLC. Actually, was invented for GM. Dick and his partners ended up creating a company called Modicon. You guys ever heard of Modicon? No? Anyway, they started Modicon, and Dick Morley's idea of the PLC was that it would replace relay logic systems, but it needed to be slow enough so you could see what was going on like you could in a relay logic system. And that was the one thing that he got wrong, because the faster your controller is, the more you can do with it, the more accurate control is, and that sort of thing. So, his initial idea was almost there, but it didn't take him very long to figure out that faster was better, so they corrected it. You can still buy Modicon controllers today. They happen to be owned by Schneider Electric. So they're Schneider PLCs, but it's still a Modicon system. Going to discuss the benefits of PLCs over electromechanical relay logic systems. Distinguish between fixed and modular, describe the functions of CPU, explain different types of memory devices, explain the use of address decoder circuit, describe the differences between discrete analog input and output. Do you guys read chapter 1, by the way? Okay.
You did a book. I'm waiting till payday to buy the book.
Okay, so the answer for that question for you is no.
Yes, that answer. I read most of it.
Okay. List major components of the power supply, describe Allen Bradley PLC devices, compare the various types of Allen Bradley PLCs, describe other types of industrial controllers, and compare them to PLCs. Does anybody have any idea what another industrial controller is? Is it all in? No, didn't think so.
Photo controls.
Hmm?
Photo controls.
That would be device.
Oh.
Describe the expansion and use of communication with intelligent industrial controllers. So, this is on the quiz. All PLCs have discrete input and discrete output. The larger, more advanced PLCs have variable input ports and variable output ports. That used to be the case. Now you can even get little bitty ones, the El Cheapos with analog, which is what the variable is. Who can tell me what a discrete input or output is? What does discrete tell you? Engineering. Sean's gonna look it up first.
Not sure. Or not sure.
No. Discrete is either on or off. 1 or 0, true or false, however you want to look at it. cannot be anywhere in between. It's either all the way off or all the way on, two discrete states. And then variable or analog is, there is a range that input or output can be in, and be anywhere in that range. Two most common are either 0 to 10 volt for a voltage input or output, and 4 to 20 milliamp for a current input or output. You also have 0 to 20 milliamps, minus 10 to plus 10, 0 to 5 volt. There's a whole bunch of different variations, but the two most common ones are 0 to 10, 4 to 10. Block diagram, that is a very, very generic way to look at how the PLC is put together. Power supply, CPU, and then input and output modules. I can't see that without my eyeballs. Yeah. These controllers on your trainers have got voltage inputs and outputs on for analog signals. So, I'm not sure what the outputs are. There are a couple of them on there too. And then Ben and Troy, your controllers also have the 16 point discrete input expansion modules. The others do not. Okay, so fixed PLC, all units are in one fixed enclosure. Number of input ports and output ports cannot be expanded. So we do not have any fixed controllers in the room. The little brother of these controllers, the Micrologix 1000, 1100, and 1200, no, I take that back, not 1200, just the 1000 and the 1100 are fixed controllers. They're about the size of a shoebox. So they are commonly referred to as shoebox controllers. Those are not expandable in any way, so those are fixed. These and those over there are modular. I turn the speakers on. What inputs and outputs you have is dependent on what types of cards you have in either the rack, which those over there are a rack-based system. There's a big number of slots that you can populate with various types of I/O, or these are just modular. They're not rack-based. Or to add a module, you just literally set it on the DIN rail next to it and plug the cable in. They daisy chain together. If you take that cover off, this ribbon cable is coming from this module. And then this module has the mating connector for, you know, if there was another module sitting next to it, it would plug in here. And so on the Micrologix 1400, this is not going to be on the quiz, but it's still good to know. On Micrologix 1400, you can have a maximum of 7 expansion modules. Any combination that you want, but a maximum of 7. CPU contains the microprocessor, memory, and support chips. Microprocessor is just that, it's the brain microprocessor unit. Address decoder, clock circuit, and peripheral interface adapter are ways that it communicates with the outside world. And the read-only memory and random access memory, read-only contains the controller's instruction set. Random access, or RAM, is where your user program is stored. And then the I/O buffers are, yes.
So what separates this from a regular computer or even a microcontroller?
Processing power. And these are dedicated to a very specific task. Their sole function in life is to control a machine or process. Yes.
Question. When we're comparing processing power of a computer, than a regular CPU, like we're talking about, is the comparison more or less like the computer may be able to do more variety, but the CPU, like you said, being much more specific thing, but also a bit more robust? Or
They
too far?
The CPU in your PLC is industrially hardened, which means it's got a bunch of noise shielding and other things on it. But I say it is for a dedicated task. You can't play solitaire on CPU for PLC. It just doesn't work. The microprocessor unit is the brains, carries out or executes program instructions. Inside the CPU, you have the ALU, or arithmetic logic unit, and then the registers for the ALU. Anybody want to take a stab at what an arithmetic logic unit would do? Arithmetic. That's where the controller processes its math functions: add, subtract, multiply, divide. Control unit and decode unit. Control unit coordinates and controls all activities. The decode unit translates instructions into a format that the MPU can understand. Would you rather remember 0001, 01, 00, 11, 001, or XIO? I would rather remember XIO. So the decoder unit takes human readable stuff and converts it into machine code that the MPU can deal with. And then the cache memory has holds the incoming instructions, and data cache holds incoming data. Those are both temporary. Needs it long enough to do its calculation and discards it. It's actually says, hey, I need the next bit of information. It overwrites whatever's in there once it's done with it. Bus. There are two different buses in the seat, or in your controller: address bus and data bus. Address bus it physically maps the memory, and then the data bus is what the actual data is transferred across. Anybody want to take a wild guess at how many bits wide the bus is on one of these controllers?
32?
Eight.
No.
16.
16. There you go. I knew somebody would eventually get it. Yeah, Micrologic's family of controllers and the SLIC for SLC are 16-bit controllers. You don't get into 32 until you get into the compact logic and above. Two types of instruction sets. CISC or CISC based microprocessor uses several math instructions to carry out complex commands. Or a RISC-based microprocessor, which every CPU and every computer in this room is a RISC-based system. Takes one instruction for the CPU to perform the complex instruction or complex command. Two types of memory devices. We already talked about that. Pardon me. Two types of RAM. This is important. Static RAM, it stores the data in internal flip-flops. Anybody know what a flip-flop is?
Shoot.
Correct.
How
How many of you think you can get inside that little box? They're got little bitty shoes.
flip-flop when relative to this thing? A physical device where memory is stored?
Yes.
Okay.
Flip-flop is sometimes known as a bistable multi-vibrator. If you turn it off, it stays off. If you turn it on, it stays on until you tell it otherwise. The dynamic, well, that's why data remains the same until it's either overwritten or the chip's turned off. Dynamic RAM holds binary data in the form of charged capacitors. They are really, really, really tiny capacitors. There are like a gazillion of them in there. And in order for them to work, they have to be refreshed every few microseconds, which is what, millionths of a second. So they got to be updated very, very, very frequently in order to remember what they're supposed to be remembering. ROM, several different types of ROM, mask ROM or pre-programmed, usually programmed by the manufacturer at the factory. And I don't know why this is relevant. The customer must order several thousand chips from a factory. You're not the customer. Alan Bradley is. So, I don't see how that's relevant. Programmable read-only memory is programmed or burned only one time by a programmer. Once it's been programmed, it's done. You can't change the program in it. Erasable programmable read-only memory can be erased, but you have to put it under a relatively strong ultraviolet light to erase the chip. And then these guys have the last one, which is electrically erasable or EEPROM, also known as flash. Guess what kind of memory this thing has? EEPROM. Let's call it flash drive. Basic input output, BIOS. The BIOS in any computerized device is the how-to guide for your CPU. Whenever you say, hey, CPU, I want to display a character on the screen, and it says, well, I don't know how to do that. So it goes to the BIOS and says, hey, how do you display a character on the screen? BIOS says, this is how you do it. It says, okay, thank you. So it goes and does it. Hey, CPU, I want to display another character on the screen. Well, I don't know how to display a character on the screen. Hey, BIOS, how do you do that? Literally everything that the CPU does, it has to go ask the BIOS how to do it. That includes printing, accepting input from the keyboard or the mouse. Serves as a communication interface between the PLC hardware and the PLC program. Address decoder. Tells the CPU says, or the MPU says, hey, I want data from this address, and the decoder says, okay, well, in order to do that, you have to go through this path. That's a really simplified version of it. That's basically what happens. Peripheral, also called support chips, used to enable a microprocessor to communicate with I/O devices. Supports the MPU by performing a different task. The ALU is a peripheral chip, usually. You guys remember the old x86 days? Some of you guys are old enough to, I'm sure. You ever have to, or did you ever get to buy a math coprocessor for your 286 machine? No? Well, I'm really dating myself here, aren't I? Discrete input modules, that is a 120 volt input on that diagram. It takes 120 volt signal, rectifies it. Do you guys know how rectifiers work? No? A little bit? You will learn that in electricity 1. Basically, rectifier takes an AC signal and converts it into DC. Then that Zener diode is a special kind of diode that basically works like a voltage regulator. Make sure that the signal does not go above 5 volts. Then the opto isolator, that is the symbol for an LED, light emitting diode. It's infrared, and it's inside a IC package, so you can't see it anyway. But the light from the LED turns on the transistor that says, hey, CPU, somebody close the switch on that input. These machines are DC inputs, so they have all that stuff minus the rectifier. The whole idea behind the optical isolator is to prevent surges from inputs and outputs, prevents them from getting to the MPU and frying it. Have an octal transceiver. What's octal?
8.
Yep. So for a 16-bit or 16 input card, you have to have 2 of them. 8 times 2 is 16. Zener diode, make sure you get a steady 5 volts. Octal latch, output value remains the same until new input bits are right over them. 2 octal latches are needed with 16 output module, also needed for a 16 input module. And then we don't have any solid state AC outputs on these controllers either. You can get expansion cards with that'll do 120 volts input and output. We just don't have them in here. Triac is basically just an electronic switch that switches AC voltage. ADC, or analog to digital converter, converts the analog signal, your 0 to 10 or your 4 to 20, into a digital signal that the CPU can understand. And then DAC, or digital to analog, takes that digital signal and converts it back into an analog signal. Which, if you think about electronic voice recorder, converts your analog voice into digital information. It's stored whenever you want to play it back. It takes the digital information and converts back into sound waves so you can hear it. Power supply. This diagram has an error on it. Any chance of you guys figuring out where the error is? I want to take a stab at it.
Voltage connected to your RC filter bypassing the rectifiers.
No. Now, the problem is with the way the rectifiers are wired.
On manuals. 3 days.
Battery.
Seems to.
No,
Battery in them, should it be over?
no.
No? Okay.
The battery is there in case the AC fails. See if I can do this. It's missing that line. Okay, so AV controllers. Use the specific instructions to implement input, output, port control, timing, counting, data manipulation, reporting, arithmetic functions, logic functions, and communication. I/O is simply on, off, or variable. Timing is literally timers. Counting is literally counters. You're either timing events or counting events. Data manipulation, that's a little drawn out explanation. We're not worried about it right now anyway. We'll get to it later. Reporting, we won't get to it all. Arithmetic functions, add, subtract, multiply, divide, logic, and or not, that sort of thing. And communication, which is how the controller communicates with other electronic devices, whether it be your PC, your touch screen, whatever, other PLCs. Safety PLC, used for monitoring and implementing safety instruction in the case of faults in a control system. No such thing as a safety micrologics controller. They don't exist. When safety controller, you have to jump up to at least compact logics. Programmable automation controller, or PAC. It is a personal computer with PLC architecture. Can be used to perform PLC functions and control electric drives and more sophisticated motion and batch control systems. If you're talking about a PAC, you're probably in a brewery or a refinery or a nuclear facility, pharmaceutical, that sort of thing. They use PACs in those. Four major types of PLCs are categorized according to input, output size, processor speed, and memory size. Micrologics and micro 800s are the smallest series of controllers. Every single one of those on that picture is a Micrologics. Those are the shoebox controllers that I was referring to earlier, the fixed PLC. Compact logics, medium size and expandable. And then control logics provides advanced capabilities for large systems. And you can control an entire wastewater treatment facility with one control logics controller if you have the proper I/O. John, what part of CU do you work for?
Blackman, water treatment.
Wastewater?
No, it's,
Well,
we treat the raw water that comes in from the rivers.
okay, so you're,
The instrument technicians, they build all this stuff in their labs.
yeah, so you're taking all the crap out of the water and fluoride, so, and fluoride and chloride.
Yeah, fluoride.
All that stuff in. Okay, yeah, there's a big difference between water and wastewater. Two completely different worlds. Compact Logics and Control Logics both use RS Logix 5000 software. In this class, we use RS Logix 500. Distributed Control System, or DCS, also used frequently in the industries that I mentioned before. DCS is basically the traffic cop. Each individual piece of equipment will have its own PLC on it. And then the DCS is God that tells everybody else what to do and when. RTU, also called a remote telemetry unit, basically remote I/O. It's usually done over some sort of wireless communication. I've been in this industry for 30 plus years and I've never personally seen one. So I would imagine, you know, Sean, you probably don't know, but do your water towers have RTU? Do you know?
I have no idea.
Okay. Your terminal lift stations probably do, and your water towers, they communicate back to your GIS, wherever the hell it's at.
Control operators.
Yeah.
It's all automated, big monitors.
That's all RTU stuff. Feature comparisons. All stuff with an X is something that in particular type of controller can do, and if it doesn't have an X, it can't. So what really jumps out at you from that chart, anybody?
Fact does everything.
Fact does everything. Communications. Just in time, or JIT communication, delivers relevant information exactly when it's needed. And you can tell that this is a rather old slide because it says field bus allows two-way digital communication between PLCs and other industrial controllers and their I/O devices. This day and age, it is almost assuredly Ethernet, IP, or Modbus. There are a bunch of other communication protocols out there, like field bus, DeviceNet, MACnet, Profinet, Profibus, a whole bunch of them. But by and large, nowadays it's either Ethernet, IP, or Modbus. And then good old SCADA, supervisory control and data acquisition. It's basically a data historian. So your You have a record of pressure, flow, temperature, any kind of process data that you need to keep track of. That is huge in anything that is the public interacts with, like water and wastewater. You have to be able to prove that you had enough chlorine in your system to kill the bugs and not have.
Can I go to the bathroom? That could be an issue.
This is not high school. You can get a deal whenever you want.
I just thought to be polite.
I appreciate that, but this is not high school. You have to ask me to get up and go. But that door is locked, so make sure you put something in so you get back in.
Yeah.
SCADA applications, sewage treatment plant, power plant, mass transit, manufacturing applications. That's usually automotive industry. They can keep track of which cars get which options and stuff.